looks almost like wakefulness, pretty hard to distinguish from wakefulness. And then there are these three kind of lesser known intermediate stages, two intermediate stages called N1 and N2. And so analyzing EEG is pretty straightforward if you just want to look at something like spectrogram. So when we did the accelerometer exercise earlier, we saw that the pre-processing that the system chose to do on it was to convert it into a spectrum. And that's the same that happens with EEG. So what happens with a lot of kind of continuous time signals, because it's a very, very powerful way of extracting kind of what's going on in the so what happens with a lot of kind of, what we want to do ultimately in sleep scoring is to identify which stage of sleep the person is in every 30 seconds. That's kind of the generally accepted the way of doing sleep scoring, is that we divide time into 30-second windows or epochs, and then you have to label it. And up until very recently, people had to manually label it because it's pretty tricky to label EEG data. It's not at all like as straightforward as this one. So this is a very good one where you can actually see this is one stage, this is a different stage. This is one stage again, different stage. And there's a difference between these two, for instance. This seems to be deep sleep, and I think this is N2. Anyway, so previously people were labeling this using human labelers. But what machine learning can do now is to kind of match human performance in terms of labeling sleep data, but it struggles with edge cases. And the edge cases are the ones that come into the sleep labs to actually do the study, like people whose sleep patterns are just messed up, they don't have high quality sleep, and so they do a sleep study to identify what factors influence their quality of sleep. And so what these sleep labs want is an automatic way of doing this, so they don't have to hire people to do the labeling kind of manually, which is very time consuming. There's a corresponding problem in 3D electron microscopy where you want to connect you want to label 3D electron microscopy data to trace the neurons through the brain to kind of understand how synaptic connectivity works. Yeah. Why is it every 30 seconds? Does sleep change that quickly? No, I think it's just a historical thing. What's been done? Yeah. So the sleep epochs, you can kind of see them here on in this one. They can last pretty short periods sometimes. Like here's one that's just 3 or 4. Or actually, sometimes it's switching. So from N3 to N2 to N1, and then back again. So in that case, at least, they needed that resolution to capture everything. So anyway, there are many of these science problems that have previously been done with human labelers that are now becoming kind of processed by AI instead. So there are commercial solutions for scoring, but there's also publicly available data sets that you can download to train your own system. And so I did this a couple of years ago, and I kind of realized that we can, in principle, do this for new data if you want. So we have these 4 computers that all have NVIDIA graphics and can run a full TensorFlow model. And so 2 of them are presented here. So this is one called Deep Sleep Net, which is a Python-based TensorFlow model for automatic sleep scoring. And so that's the one I implemented. So this one claims to have about 80% accuracy on different data sets. And it's publicly available. You can download it on GitHub. So it looks like what you see on the right here. And so here you can actually see the 128 here means number of neurons in that layer. So you have these different layers. This is an LSTM network, and so further down here you have this this loop, which I don't understand. I don't know what it does. I thought it was recurrent, this loop. Whatever. But anyway, so you can push 30-second EEG epochs, like even an individual epoch, through this system, and at the end you can see that it says 5 softmax. So those are the 5 possible stages of sleep, and the system will classify every kind of sleep data set into one of those categories. I'm starting to think that what we're going for, at least one thing we're going for, is something like a hat that you can put on that notices when you get tired and flashes a red light, or it notices excitement or fear. I know, Greg, that we've already kind of done EEG, but I mean, this we're neuroscientists. We want to record from the brain, after all. And with this data, with this network, you can kind of label EEG data into 5 different categories. And as far as I can tell, we could pick any categories and just.
This was done in real time. Or was it just like?
No, it's done afterwards. Yeah, you collect the data and then label afterwards. All right. So I have the instructions for how to implement that network. It takes a long time. It needs a lot of GPUs. It needs to be set up properly, but we've done it before, so we can do it here. And we have four of these laptops that in principle could process this kind of data, and then we would get Stanislav to convert it from TensorFlow into TensorFlow Lite, and we could deploy it on a Arduino, and everything would be good. So I just wanted to bring that up as a possibility, as something we can also play with. All right. So let's go back to. Let's now go back to where we were with Edge Impulse. All right. Okay. Yeah, go for it. Okay, so if we look, in the on the dashboard here, it's going to tell us how much of the kind of process, how much of the tool chain we've worked through. And here we have 100% complete. Everything's done. This is the same project I was working on before lunch. Where did we end up? 89% accuracy on the training data set. But as we found, it's the testing data set that matters. And here we had an 80% accuracy after we cleaned up the data set a bit and added 30 neurons to the network. And so the thing I'm hoping we can do going from here is deploying this on the Arduino and then modifying the deployed code such that certain pins on the Arduino will output when their label is detected. So we will assign one pin to each of the 3 labels that we have, and then hopefully when I move this around, disconnected from everything, we can make it do a light or a tone or something. Yeah. Okay, so we go to deployment, and then you just click once on Arduino library, and that selects the type of output we want. Don't click on Arduino Nano after, because that's going to generate more of a binary that you can flash on the Arduino, but that won't be editable by us. So just select Arduino and then click Build. Okay.
Doesn't matter if we do int 8 versus int 32.
Yes, it definitely needs to be int 8. Where does it ask about that?
There.
Oh, this one?
Yeah.
Yeah. So the whole point is to go from float 32, which is the kind of standard TensorFlow implementation, down to 8-bit, which is TensorFlow Lite, which is the only reason that this thing can even begin to accept running AI systems. And I have no idea how they did it. It's a collaboration between Harvard and Google, is it? It must have been difficult. Okay. All right, so Why did I get a zip file? I didn't want to get a zip file. Arduino library. All right, so I think, if I remember right, what you're supposed to do with this is, do you guys have Arduino, like normal Arduino installed? So yeah, so download the Arduino IDE, otherwise, and then I think the way you're supposed to do it is include library, add zip library, go to downloads, and then add the zip file that the system created for you in Edge Impulse. Okay, so once you've done that, yep.
Quick question, where are you getting the sketch that you're opening? Or should we have a sketch with
No, so I just went to, so I just opened my Arduino app, and then you need to go to Sketch and include library and add zip library. And for some reason, this is how they've set it up. And then just find it's going to look something like EI Edge Impulse dash whatever the name of your project was dash Arduino. So you find that one, open it, and now, if I go to examples and I scroll down to here, it says here TinyML Day 2, which is the name of the full name of my project, and then it says inferencing. So training is what we do on the cloud with big computers, and then inferencing is the kind of snapshot performance of that model for individual data cases. All right, so I'm going to go to accelerometer continuous. I don't know why it always gives you these 5, regardless of what you've been doing, but I'm going to go to accelerometer continuous and see what that looks like. So you can see here that it's going to start a serial channel, and it's going to be printing its results every couple of seconds, I guess. So let's just try this. This is going to take a little while to upload, but basically go down to port, find your Arduino. Here it actually says which port it's on, so you don't need to mess around with device manager. So make sure you have the right board, right port, everything's good. And then I'm gonna hit upload and go get a coffee, because this is gonna take like 10 minutes to run. Yeah, again, if you ever worked with a normal Arduino, they upload like this, or at least relatively quickly. Oh. Uh-oh. Okay, so I got a bug here saying Arduino LSM9DS1.h.
Yeah, you have to include the library for accelerometer.
So you go to your library manager, and then I search for Nano BLE maybe? No.
Search for the exact name. Yeah, search for the exact name. Arduino _ LSM9DS1.
There we go.
Yeah, please install that.
There's 2 of them. I search. Oh, I'm gonna get the Arduino.
First one, yeah.
Yeah. Good. Try again. So the pain with this kind of part of it is that compiling and uploading really does take about 10 minutes. Therefore, you may not see an error until 8 minutes into it. Debugging becomes a real pain. If we want to, at some point, I think we'll have to show you how to kind of maybe disable large sections of this so that you can kind of edit only the part of the code that like controls LEDs or something, but because this is not how you're supposed to check whether your code is working. All right, so while we wait for that, I'm going to show you what we're going to do down here. So if I want this Arduino to kind of blink an LED every now and then, first thing I need is to know what the pin layout is. So I'm going to go Google, go Arduino Nano 33 BLE pins. And I'm going to go get a bunch of schematics, pick a good one. There we go. All right. So the Arduino Nano can be powered on the V-in and ground pins. However, to do that, you need to break a little pad here on the back. And so they recommend that you only do this once you've fully deployed and tested your model. So in the meantime, we're going to power it just using the USB cable, but we're not going to transmit any data through the USB cable. So it's all going to happen on the chip. And so then we need to pick 2 pins that we can use as, no, 3 pins to use as possible outputs for the system. So basically you want to pick one of the digital pins on the right side here. So we can just do 2, 3, and 4.
Also there is RGB diode on the board. So if you want to use that, you don't have to solder anything. So.
Yes. So I wanted to be able to show the different outputs.
No problem.
All right. So what we have here are these little very handy cables that come with a. Do we still call it female, or is that incorrect? That one. And so we have a few of those that you can just plug onto your board. So you don't have to do you don't have to use a circuit board or anything, but if you just plug one of these on the right pin, let's see here, pin 5.
That's what you can open. That's what you can open.
5, 6, and 7. Oh, I don't have that many. Yeah, I do. There's more if you want. So what I want to do is to have the Arduino board output output a voltage or output voltage on this pin, on each of the pins when the correct label is detected. And so to do that, we're going to go back to the code, which is still compiling. Right. And then check where exactly the detection happens, or where it's outputted. So what this thing is going to do is it's going to run an inference every second or something. No, maybe every 2 seconds. That's the size that the system was trained on. So maybe every 2 seconds or 3 seconds. And so that's happening. That is happening. Well, this one is a little bit different. This oh no, down here. There we go. All right. All right, I'm a little bit stuck here because, so I did this with the sound detection to have the words yes and no trigger an LED change. But when I did that, the detection section of the code looked very different. So it looked like this here. So it was in the main loop. It had a very clearly labeled variable called result.classification.label. And that was the actual value.
Yeah, if you can share the file, maybe I can also look into it.
Yes, yes. Let me.
It's not 110.
It must be this one, right? Smooth count. Okay, I'll send it to you.
If you go to the function right in static,
Yes,
it should be
yes, exactly. This one. Blocked for security reasons.
You can just save the sketch, just that one file, and I think that will go through
Okay.
in Arduino.
I'll save the sketch. Yeah.
Just go to your Arduino and save the file.
Yeah. Oh wait, which one was it? No, the other one. This one. Okay, done saving. That's good. All right, see if that. If that works.
Okay, waiting for it.
prediction.
Say again?
This is a variable called prediction that we print when you run the classifier.
Oh yeah, yeah. I'm just waiting for it to finish uploading because when I see what the serial output looks like, I'll know which variable to mess with. I'd be happy to play around with it, but when it takes 10 minutes to to try something.
Chris,
Yeah.
quick question. Let's choose two. So let's say it's the library that we should be accessing for this one.
Right. So you downloaded the deployment zip file and you you open that as a library. Yeah. Then go to Manage Libraries. Oh, which will not open. Oh yeah, here we go. And then search for. Let's see if I remember now.
Oh, you mean the LS?
Yeah, what was
Oh,
it?
okay. So we already have that.
Then you should be fine to just upload. So actually, and if you want to generate that name again, just try to so you've loaded the zip file, and then if you go to examples at the bottom here, you'll have your project name there, and then if you pick accelerometer continuous,
Okay.
that should be the model we trained. Okay, I think that's done. Now, first I'm gonna restart it. Just clicking the restart button just in case. And then if I go up on tools and serial monitor, whoop. Oh, because I clicked reset, it switched port, I think. Now it's on COM4. Okay, serial monitor, there we go. Why are there 5 labels? Okay, yeah, it's working. Okay, so it's the output is a little bit weird. So 10 is complete confidence. You can see that the name of the most likely label. So if I just leave it sitting there, it's going to go to uncertain. I don't know why there's a 5th label after uncertain. I have no idea what that is, but it doesn't matter. So the 4th index is uncertain. Window cleaner must be number 3. Oh no, which one is it? 2. Yeah, 2. Window cleaner is 2. Jedi is 1. And is snake 3 then? No. Okay, snake looks like it's number 2. So Jedi is 1. Jedi is definitely 1. I can easily get Jedi. Snake is 2.
I'm sending you back the.
Oh yeah? Cool. Okay, the snake is terrible, but it's on number 2, and then number 3 is the window cleaner, right? No. All right. So the performance of this model is so poor that I am going to go back and give it more data. Yep. But first I'm going to have a look at what it's going to say.
Actually, I did a hack. I just read the first letter of the classification result, and based on that, made a decision which class is.
You read the first letter of
the string of the classification results. Yeah.
Oh, good. All right.
Yeah, so
excellent.
That's the
Okay,
quickest fix that I made. Okay.
Good. I like it. Okay. But So these all have the same 0 here. You mean 1, 2? No. You do mean 0. Yeah.
No. The 0, the first
Yeah.
character.
Yeah. Okay. Good. So, but I'm gonna go back to our model here and have another look at what's going on. So, in data acquisition,
I think that precision will drastically increase if you are aware all the time how you hold the board.
I know what you're saying. I don't want to make it easy for the AI.
Okay, then we have to give it a lot of.
All right, let's do it.
Yeah, examples.
All right. Oh wait. So what did I do now? Oh yeah. So now I've ruined my controller because now I uploaded a completely new sketch to it, and so now I need to go back and bootload this thing to be able to have it pipe data straight into Edge Impulse. So probably we should have 2 of these each. Maybe, I don't know. But I'm gonna double click on the board to get it into bootloading mode, little pulsing LED, and then I'm gonna go on my Windows Flash file, and then it's gonna start to reinstall Edge Impulse on the board. Okay. And then I'm gonna just briefly stop sharing here so I can tell these guys I can't. Okay, so okay. So my Arduino has been reflashed and should now be available just like that. Maybe I need to at least restart it. And then if I go connect using web USB, it appears and seems to work. Oh yeah, I did it. All right. All right. We are back. So I've reflashed my Arduino. Once I uploaded the model on this thing, that's different from the Edge Impulse firmware, completely different. And so you need to, when you switch between them, each time you need to upload all the files to the Arduino. So flashing it is what I do with these 4 files, or well, with the OS specific executable and this one, and then the model that I use for deployment at the end of having trained everything in Edge Impulse looks like is a zip file that I load directly into in the Arduino IDE. So it looks like this. All right, but so now I've reflashed. So now this is loaded with Edge Impulse again, and so I am just gonna start collecting a whole bunch of data. Jelly. Maybe I'll go crazy and add another label. Oops. Okay, that last one I'm gonna delete because I did that with my other hand. Hmm? Oh. Um, All right, one more round. Let's see what we can do with that. So first, because I did, okay, remember now that when you do data acquisition up here, it's going to tell you training data and test data, and it's going to expect you to go to test data and generate new data points to put here, unless you go to dashboard and rebalance the data sets, which is going to just split your data 80-20, I think, into training and testing data. Rebalanced, impulse design. I mean, there's also a lot to mess with here. Window size. What is my ideal window size? Window increase is just 80 milliseconds. That's really overlapping the data a lot. On the other hand, you get more data points.
In my opinion, that's okay. Window size in general, you want to match with the frequency of your signal. So if your signal is, if one movement is a pretty long, if you want to detect low frequencies, then you have you need bigger window. If you're classified just on the high frequencies, then your window can be smaller. So
maybe more then. Whatever. Okay, I'm not going to mess with this before I see how it performs with the additional data. So because then I won't know whether the data helped or whether the changing features helped. So I don't know if I need to redo this. I think maybe it doesn't look nice. So, okay, so what we're looking at here are all the data points in the data set labeled in color to match their label, their ground truth, what we told the system. And the reason that I think that these happen, you can actually see that this is a single trajectory through here. That probably was just I don't know.
Yeah, probably Jedi, because you're doing random movements. Jedi contains the movement for example, window cleaning. Okay, because you are doing something like this. So that's why.
Yeah.
I mean,
so it's not the end of the world.
Yeah. If you take maybe bigger window will discriminate better for Jedi. But let's try with this. See what's the.
Okay. Yeah. Cool. Let's just see what we get first. Okay. I did have those 30. Oh, no, I'm not going to mess with this. Let's just do it. So I have the option here to retrain the model. I think maybe I just do that. I don't think I need to recreate the filters or set up the classifier again. I just retrain the model. Okay, complete. Let's go to model testing and classify all. Good. 78%. Window cleaner is the problem. Jedi and Snake are now very clear. Window cleaner still struggling a bit.
Confuses with Jedi.
Now, yeah, so I've been told that you're not supposed to simply add more examples of the the data point or data type that you're struggling with. The data set should be balanced in terms of the different labels.
Exactly.
Which I guess makes sense. So, but let's just see how this performs on the... No, let's mess with it. Let's see if we can do better. So first of all, I put these 30 neurons in there. That may have been rubbish. Just take them out.
Yeah, I think that it will be better generalization if you have less number of neurons.
Right.
In general.
Right.
Also,
less opportunity for overtraining.
Yeah, one more thing maybe that will be interesting. So if you are taking all those recording and ask from Edge Impulse to shuffle and divide into two separate for a training and for testing, then it might be that almost exactly the same data will end up in a testing and a training, because it will take one window and put it in a training and then move 80 milliseconds and put it in a testing, which is basically almost the same thing. So because of that, you probably want to dedicate whole recording to training and whole recording to testing, if you understand what I want to say. So
I do. I think it is doing that. I have a feeling it is doing that, because here it looks like 10 seconds in the test data list.
Okay, great.
So, I mean, yeah. So I think that's good. So what did I do? I just took neurons out. Let's just try that. Back to training model. All right. Accuracy over 90%.
Yeah, generally you want to lower number of neurons. If accuracy is still there, you want to lower number of neurons as much as you can. Then you know that the generalization will be good. It won't overfit.
But even the model performance, I think, went up. I don't know.
Great.
I think it went up. Oh, anyway. Oh wait, I shouldn't have done that. Let's classify. Oh wow, look at this. So you can actually see here, there's one here that was terrible.
Yeah, let's remove that and add a new one.
Right.
Yeah.
There we go. This is what they call p-hacking.
Yeah. Actually, probably you changed how you move from the you know, 3 hours ago and now. So
right. Yeah.
If I may observe that you moved much more quickly this time when you were cleaning the window than the last time.
Right. Okay. Well. So accuracy good, but we had good accuracy last time. But maybe it's fine. No, you know what? I'm not going to be lazy. I'm going to give it some more data. only way through this. First, I'm going to replace the window cleaner data set.
Yeah.
Actually, I got it on Amazon. I can send you a link. It's a pretty basic like starter kit that works. I'm sure there's some lying around here. I just have this background. One photo is all. I'm sure it's not. Oh. Okay. Okay. All right. I'm ready. All right. Like what?
Oh, back one.
Some things, some medication. Yeah.
Someone's on the phone.
Okay. See you.
Well, you can do that.
Like I can't miss this call. It's such a good afternoon. I forgot to use the phone that are just in your cat. Messenger of this long conversation. Instagram. It's really sweet. We should do this.
Will you attach the foundation? I am not attaching the cups. It's a thing powering. Are you supposed to do oh, you do that. Who would you do that? How do you do it?
Well, no, I think what they're doing is take it off the board. And then the female ends, you just figure out where you want to put it.
Right, and you have to, I mean, to the other side.
Yeah, so some people do it where you like, you can attach it here, and then you like, you know, take off this part, like solder it to, or not solder it, like route it to the bulb and LED. Either way.
So, how do you attach that? How do you do that?
Yeah, you push it on. It's not very thick, but yeah, it puts a little bit, yeah.
I'm going to also mess with the window size.
Oh.
Let's make it 3 seconds.
Let's see now.
You have to generate features again, I think. I don't know if it will generate.
Oh yeah, there's more data, right?
And a different window size.
And the what?
And a different window size. If you want to apply a different window size, then you have to generate features.
I see.
Maybe you can enter the number, I don't know.
Hey. Efficient. Can I have 2 learning blocks? What is that? Okay, I mean, anomaly detection. Oh, wow. Yeah, no, I don't want that. Okay. Save. Spectral. Okay, and so now spectral features become gray again, and so you have to recreate those, I suppose.
And there goes 25 minutes.
Yeah, exactly. Okay, what are we looking at here now? Well,
This looks better.
yeah, still a little blue in there, but never mind. Okay, so we did the features, classifier, number of training cycles, minimum confidence rate. Oh, here's the uncertain thing. Okay, so it's saying if it's below 0.6 certainty, it's going to classify it as uncertain. What can I do here? Dense, pooling. Ooh, dropout. Okay, after we do this, I want to mess with dropout. So dropout is another important theoretical advance that's also down to Hinton, I think. And it kind of means that you train the model and then you just kill half the neurons and you train the model again, or you randomize half the neurons, something like that. You kind of purposefully sabotage the training. And by doing that and then retraining, it's like the network becomes robust to overfitting a little bit. So dropout is a method for preventing overfitting, because you're making sure that it doesn't rely on like one or a few highly important neurons. You want to have more of a group thing. So start training. Okay, 96.5% accuracy, a lot higher than last time. I'm not going to retrain the model here. I think that's unnecessary. Let's go to model testing. Oh no, I should have balanced my data, shouldn't I? Shit. Okay.
You can make it 3 new recordings, and assign it to testing.
Yeah. And just add it to the testing?
Yeah, just to the testing. And then you will test just on that.
Where would I add that though? I don't.
In the data acquisition, I think that you can select there.
Yep.
Yeah, and you can see on the pie chart there, or donut chart, how many of each data you have.
Oh wow, okay. Oh wow, okay, well that's good to know.
Yeah.
30.
But probably some are assigned to testing and some to training. We have to go through the data and see which one.
Oh, but it's different here. So yeah, no, wait. So I'm gonna go here and rebalance, because even if I add some, I'm not sure it's balanced. Rebalance. Now what does it have? Okay, pretty equal. Close enough. And test data. Surprisingly unequal. Okay, I'm gonna add a window cleaner and a Jedi.
Yeah.
No?
Yeah, or just remove some of the some of the data that you have for testing.
Yeah.
You're doing snake.
No, I don't think you need that. Yep.
You just
No.
you just you just did the snake for window cleaner. Yeah.
Yes, yes. But I can
That's
change
cool.
the label here. Edit label.
Oh, that's cool.
Yeah. It still keeps the sample name, which is a bit confusing, but I think it's the label that counts. So I think we're good. So that's pretty balanced. This one just needs one more window cleaner or two. I wonder why I have to reconnect this every time. Window. One more.
Also, it's called nice to not see his brother's
Oh, yeah, that's aim for more high fish, but like, you know, not very
Wow. Okay, so yeah, so retraining. I wish it would tell us if this was necessary. Retrain model with known parameters. I don't know. And anyway, now I've added a few more data sets, so I should be recreating my features and everything. Yeah. So save impulse, just accept kind of what they give you here. Features. I've been underestimating the feature extraction part of AI. It's frustrating, but it's important.
Yeah, for old neural networks like dense. Yeah.
Yeah.
The whole trick is in selecting features.
Right. Okay.
Oh. What do you call those? The 3D diagrams. Because I've seen a couple of videos.
Do you know what it's called, Stanislav? The 3D diagram itself with the 3 points. It's like a separation matrix or something.
With the features?
Yeah.
Input data space, but you have just three. You
Right.
choose just the three dimensions, so, because
Right.
we cannot see 33.
Yeah.
That's the space in which neural network is classifying, so input space.
Feature Explorer. Yeah, and so this anyway is only one of the many dimensions that or three of the several features that the network is looking at. So even if something's looking like unseparable here, like here, that doesn't mean that there couldn't be other features that make that fix that. Okay, I did that one. Okay, I'm superstitious, so I'm going to retrain every time. That's basically my answer, because I don't know.
Is there any way to get $1 in cash? Yeah. We will Venmo you either $1 for in cash.
Really?
And you know the $1 that we missed is that $1 from that story that he gave us right now. We have to bring back. They can transfer cash and do it. And we are $1 short. That's just so funny. Thank you so much. We will Venmo you the $1. Okay. Sure. Wow, Sam. You're too good for your own good. So too nice for your own good. You gotta be a little more.
All right.
Less altruistic.
So now it's starting to look better. So now we have an accuracy of 93%. This was not hitting 80% just a few rounds ago.
Great.
So that's good. So I'm going to actually go straight to deployment and generate Arduino code for this, and then integrate what Stanislav sent me so we can get pin control to correspond to feature detection. Yeah, I'm starting to get this now. So you wanna have.
Yeah.
Oh no! So we kind of want a bunch of sensors to start with. Like you pack a person full of sensors, and then we need to kind of label their whole day. And then at some point we'll train different networks and see which of the labels can be extracted from which of the sensors. Something like that. I mean, there must be a million hardware companies doing this. I feel a little bit like we need to make sure we stay close to neuroscience. So just a little, otherwise we're competing with like the Muse headset and the Fitbit, which I don't know.
Yeah.
A whip or an AA detector.
Oh my god.
So I'm doing.
Are you sure I think that?
Okay, so I got this. I will close these. Open up Arduino.
You like whip grenade.
I will load the zip file, which has a very similar name, but ends on a 2 instead of a 1, such that in examples later I expect to know. Why is not 2 there? Okay, I think that this one overrode the previous one. So I'm going to go with the. Ugh, that's annoying.
You can always delete the library, so and then import again. So usually Arduino is storing libraries in My Documents, Arduino.
All right.
So yeah, you can close Arduino IDE, so you don't confuse it.
Yeah. And then docs.
And then yeah, just delete your libraries.
All right. Okay, so I have to be.
Delete everything that's connected to your project and import again.
Yeah.
That's the bulletproof way.
Yeah. All right. So I've got this one. I'm going to re-import the zip.
Oh, it's just that you can't touch it there. That's the
Right one.
Yeah, that's there. It's counting as a character.
Yeah, let's the same. Okay, so I go with this one. But first, I'm going to go have a look at the code. Stanislav sent, which is the name.
Do you want to experiment immediately, or do you want to run once to see what will happen?
Yeah, you're right. All right. Yeah, you're right. Okay, let's see if this works. Yeah, that one picks the right one. Good. Okay, Arduino is ready. IDE is ready. I upload or start to upload the sketch. will take a while.
Did you already add the pin number?
No, so I haven't done that part yet. We just want to make sure that this is working first. No, that the network is set up right, because otherwise I'm going to have to edit the code again. But if it works, let's see here. So where did I save that thing? Oh, modified dot, so open up another. So while this is compiling and uploading, I'm going to open the modified file that Stanislav sent me just now from downloads, if I can find it. Here we go. Modified. Okay. So the way the sketch works is that it's outputting a couple of different things in each time step. So one is the prediction variable, which is a string that gives you the most likely label, like the how, yeah, it gives you the top probability label for the current prediction. And so the way I did it here was just to check the first letter of that prediction. And so we have Jedi, Snake, Uno Cleaner, and Uncertain. So this should work perfectly fine. And so what I'm going to do is get the code I did before to do this. It's here. So there's a couple. Oh. Is that it? No, that's not it. No, close them. Here. Here. And they all have the same name. All right, so I want to declare which pins are going to correspond to which labels. We have three labels, three relevant labels. So I need to do a couple of things. At the beginning of my sketch, I need to declare my pins. We have a Jedi pin. We have a Snake pin. And we shall also have a little window pin. Window pin. Oh, wind pin, of course, wind pin. All right, and then we're going to use, I think we said digital 5, 6, and 7, but let me check. No, digital 2, 3, and 4, which are on pins 5, 6, and 7, but this is a common confusion. The pins and the digital pin number are not the same. And so you need the digital pin number and the actual pin. So 5, 6, and 7 are the ones I've already attached a little outline to. I'm going to need a ground connect as well, actually. Well, get to that. But digital pins 2, 3, and 4. So if I'm back here. Oh, this is where I wanted to do this, actually. Sorry, I'll come back and explain this in a bit. Yeah, this was not right. Okay, digital pin 2, 3, and 4 have been declared. Next, in the setup section of the code, we also need to make these particular pins output pins. That's how Arduino rolls. So we have our Jedi pin, our snake pin, our pin, our all output. Good, finally. So the Arduino, what the Arduino does is that first it runs the setup and then it runs the loop. That's it. That's all any Arduino does. But in the loop, it's calling another function, believe. Well, I don't know, but yeah. So when is run inference background called? Oh, there it is. Thread start. Okay. Yeah, so they've complicated it, but basically within this part of the code, run inference background, there is a section where prediction is generated. And that's the name of what the AI thinks it's looking at. And so I'm going to look again at what Stanislav suggested. There it is. So right under prediction, we're going to inject a little bit of code. This part is actually really important. So using edge impulse, we were perfectly able to generate an Arduino library that will run our network. But the way the Arduino will then sit and run that network and run it and run it and run it and run it. But then what? Like it will output what it thinks it's looking at to the serial monitor. And that's it. It doesn't do anything else. So then you need to be able to kind of modify the Arduino code to not just send its output to the serial monitor, but to do other things as well. And that's what this part is. So where it's about to send the information to the serial monitor, or rather exactly right after it's made its prediction, is where we kind of jump in and inject this code to check whether the prediction is to check which prediction it's made, and then if it's made our prediction, the particular prediction we are interested in, we're going to go and make it say something like this. So if the prediction is Jedi, I want it to do to Jedi pin right high, and otherwise Jedi pin right low. And then I'm going to cry a bit about the curly brackets.
No, yeah.
And all.
Sorry. You can just put high and remove everything else, and at the beginning you can just reset everything to low, and that's it.
But then it's going to blink. I don't want it to blink.
No, it won't blink. But this way it will never end. Okay, however you want. Sorry, I don't want to interrupt.
No, this will work. And so I'm going to do the same thing for the snake pin. Snake pin. And no. Oh, wind pin. Can I automatic indentation here at least? No?
Maybe auto format in the tools at the beginning.
Ooh. No. Yeah. Well, whatever. This is very hard for me to read. I hate curly brackets. Oh, okay. I'm gonna assume. No, I can't assume that's right. That's the problem. So now when I upload this, it's not gonna tell me if I screwed up the brackets until the very last moment. So let's see. Start end, second end. That's not.
Yeah, and you can maybe remove the square bracket around S, W, and U. I don't know why it's there. Maybe I added it, but by accident.
This one?
Yeah, when it compares at the end, there is a U, but there is a square bracket around U. I don't know why it's there. So you can remove the square bracket.
Right. What, this one?
Yeah. Those two.
Right. Well, they are. Oh yeah. I see them. Okay. This one shouldn't be here, right?
Yeah, you can remove it.
Roll up. I'm not seeing.
No, I don't think that should be there. Let me see.
Oh, you might be missing one on top of the if variables EIN. I'm not sure that's true.
Yeah, so this one's there, the next one's there. Then this one comes in. That one goes. This one goes, that one goes.
Oh,
It looks like everything.
right? It's hard to tell if that was moving it so far. Parentheses.
Good.
Wait, but if your code runs like in the first if statement, if it runs the prediction and it's true, and then it goes into the bracket, and then it hits the else statement and it runs that, then it's not gonna run anything afterwards, right? But shouldn't it run because it's an else if afterwards?
Yeah, but the prediction should only ever give a J if it really is Jedi. So it doesn't need to check anything else. It can only be one right answer, right?
Yeah, it probably compiler will run error.
Hang on.
What's the point of the low statement then? It's your right low. If it's true, then shouldn't it be high?
That's a very good point. Mine makes a good point. Okay, let's kill the if statements, the else parts, and just do. Yeah. Okay. It's a bit inelegant, but I think that's right. Let me try to do auto format. Good. So now this came up where it should be. All right. Anyway, I think that's done. In the meantime, the Arduino finished loading. And you can see that just down here, this is how it looks at the end, where it actually does the uploading at the very, very end after checking everything and compiling and so on. And so before I even load this code that we just modified, I am going to go to serial monitor, but my board has moved around, which happens. It's on 4 now. Back to serial. There we go. Okay, uncertain, snaking it. There we go.
Yeah.
Snake, window cleaner. There we go. Okay, so it takes a little while to kind of get going.
Yeah, because window is 3 seconds.
Ah, yeah, good. Okay, and then Jedi should be good. Yeah. All right. So now,
Wow, bravo.
yeah, now we got enough data in there that it's pretty solid. So I will check my code one more time. Two, 3, and 4. Jedi Snake Windows. And then Jedi Snake Window. And they are output configured and declared. So that should be good to go. Let's try it. All right, and so while this one is uploading, I want to
Are you thinking like they do stuff?
yeah, just
I might have it on.
Right here.
Oh, there are. Okay. Perfect. Okay. This is sales. What else is that? The real question is, Jedi.
all right. We will do a little bit of soldering to attach the this is another.
Like the file?
Yeah.
You need like pick up. No.
Oh, okay.
No, you want to open it. You can open it from the.
It's like from the library.
From the zip.
All right.
Yeah, I'm not able to open it.
Oh, really?
It's now telling me that the board was not available. Not sure why.
Okay,
I'm gonna restart the board.
No, it shouldn't go
Okay,
this.
I left it to go on.
It shouldn't go this. I would like. It's like.
Maybe the perfect thing would be that fellows also repeat this kind of experiment with their movements. Then they will figure it out.
Yeah. Yeah. Security equals false. Okay. All right. So this is done now. The solder what? Oh, I restarted it and then I went up to tools, and if I just look at this one, it will usually tell me where it is.
Yeah.
And in fact, it's now jumped again. So I'm gonna go here, and then I want to check. So this is still good, or not? Oh yeah, there we go. Okay, so it takes a little while to get going, which I still find weird. But anyway. So we have the pins connected, and so now
Library, add zip library.
I need to find a ground. Ground is right there.
Yeah.
And I'm supposed to be wearing gloves, and I'm supposed to turn this off probably. Yeah. There we go.
Yeah, we're here.
Okay. So it was Jedi, and when you connect an LED, the resistor needs to go first, and then the LED, and kind of in the direction of the circuit. So resistor first, and then connect that to the long leg of the LED, and then connect that to ground. Oh, in fact, I have these right here. I'm one ground pin short, so let me just focus on the Jedi and the window cleaner. No, let's do the Jedi and the snake. The Jedi will be green, the snake red. There you go. So, this ground.
It's a lot of lines of raw code.
Oh no. Okay. So I was holding the board upside down, so it wouldn't have worked. That's down. Okay, that's down. So. First one. Okay. So right now I have 2 contacts to ground and 2 contacts to digital pin 2 and 3, which is the Jedi and the snake. So first I'm going to connect the Jedi pin to the resistor. So I've got these 200, oh, I don't even remember, 250. I don't know, but it's the right one for LEDs. There are calculators online to give you the right resistor value for normal LEDs. It's something like 50, between 50 and 200. Yeah, exactly those. Yeah. And Okay, so from Jedi pin to resistor to green LED. And back to the board, back to ground actually. Back to ground. And then the snake pin to its resistor to red LED and to ground. Okay. All right, so we have this little tangle of resistors, one resistor in series with one LED, going from pin 6, which is digital pin 3, to ground, and from pin 5, digital pin 2 to ground. And now, finally, I just need to connect this to a battery. A battery.
The battery in the box.
No, like a USB battery. Hang on, I'll go get one. Those characters.
Is it power from the laptop now?
Oh yeah, it's enough. It's just we fought so hard to have this run on its own. I'm refusing to have a cable connecting it to a computer that, in principle, could be doing all the heavy lifting. All right, so connect and connect. Make sure these are not shorting somewhere. All right, a little messy, but let's see. All right, so. Oh, I can't do the movement then.
It turned on.
It did?
Yeah. The green one.
Shit. How come I did? Snake. This is terrible. Oh.
Did you try the Jedi?
The Jedi turned on.
I did try the Jedi, and I have to remember that this takes a little bit more time. Okay, I'm not going to hold the battery with the thing. So. Come on then. No? No. Oh wait. That was kind of messy anyway. This is where my lack of engineering training comes. Yep.
There we go.
Yeah.
Okay, so part of the problem is that these LEDs are too big for these resistors. So I was using these kind of classic, but the smaller LEDs basically, and these are huge. So let me just go upstairs and get a couple of smaller ones.
One LED. I've done that before. Yeah, the nano should change colors. There's a whole like key weight for activity that you can do. Of course, that changes color based on like what you tell it. Well, yeah, you're supposed to say things to it, but like you kind of have to yell at it because of the way the device. Right? Yeah, I got very good. I'd be like, yes, no, no. I was good for it. It was fine. Especially because it would happen to like, it would happen for a while, so and it would just be repeated yelling. Sorry, this is, weird, but it's not that bad. Actually, it got better because I reconfigured it to be like other custom words, like left. And so it was just like turning left and right. Which,
You got the probably again or not?
no, unfortunately, I also get too nervous.
Oh, yeah.
Not nervous, it's just like, he's really in this kind of slow state. I don't want to.
Yeah. Wait, hold on.
What did you do? What happened? Yeah, really?
I think it's here.
What do you mean it's here?
It's a file.
A
I
file?
didn't get an error.
What the hell? How'd you open it? Was it just like you just select the library?
Yeah. So I did you install your home through?
No.
No, you just have to
I just have, yeah, I just
Yeah.
downloaded it from the website.
Okay, so what I did, I downloaded it in Homebrew originally, in fact, I uninstalled it, and then I reinstalled it. And then I did some other stuff, I'm pretty sure, and I installed it through the website. So maybe you could just uninstall and reinstall?
Through the website, you mean?
Yeah.
Yeah, I mean, I installed it, like last week.
Yeah.
It's the same version. I should see if there's like a. You would have been imported it as a library, right?
Well, maybe I didn't care.
You have to split everything. You have to find what your output means,
Yeah.
and that's in the space, and then that's to get to. I believe the loop page. I was just constantly checking and saying if the results is this, you do this.
Maybe just the next.
So there's three technically components of breaking out.
Okay.
You have your libraries that you integrate, you have your setup, and you have your presentation. So once your library is initialized variables for your output exposure, associated with different ways, and then those you actually just kind of, okay. You talk about this result associated with PIN,
Yeah.
get your LED going.
So where do I find the conclusion? That's that. Here. I can't.
Do you have any other base codes, like the, under like,
It did.
okay, no, we fine. Like under the sales page. Example, under examples, file examples, there's some base ones that you can take a look at. Like for example, there should be, if you download this. Would you like our key orders for like
No.
no big deal. So there's just some I Google that you can download But there, it should be pre-downloaded. If you check file examples and just see if there's, it should be under examples for any board or if you have something. And if not that, you ran the accelerometer actually, right? Like a simple accelerometer where you can move in space and it's on serial water to show you what's happening. Oh, you did this? Okay. Oh, okay. So. Yeah, okay.
That was still too weak. It was still too weak. We're gonna do 20 ohm, not 50, because these LEDs are giant.
Should I open up the?
Yeah, so those are all sketches. So the way this works is, running this, it just comes through. It'll just give you a count. Normally when you're doing your own first. Okay, so the file is directory, so we're just going to find out where it's creating. So, files. The center. Yeah. So yeah, like that. Well, okay, here you go. So,
Really? I apologize for the interruption here while I reduce the
wait, hold on.
strength of the resistor to get this thing to actually light up.
Yeah, I just need to know like what to do after.
I think it's working, but it's kind of weakly working.
Yeah, that's weird.
Oh, okay, awesome, yeah.
I just don't know what to do after.
Yeah, so you just loaded in some moves to do as any other thing. Because essentially what this is very.
My Jedi. Yeah, it's there. It is working. It's just too weak for these LEDs. I need a even Wimp your sister.
So what data did you?
Okay. That's fine. I think this is fine.
Oh, it's a double tap? No, it's.
Also my house.
I personally think that this is the hell. Okay. So, yeah, use this plugin. So, upload it, it basically just changes the topic.
Truly no. I assume so.
So it's a Mac, so we should, sorry, this is, let me just check.
I'm so sorry.
It's not your fault, it's just me not used to it. What you need to do every time you, before you upload these sort of reports.
Okay.
So for this, for example, it's on Arduino Uno, which we do not want because this is not Arduino Uno.
Right.
So what we need to do is we need to go to embed OS boards and then click on Arduino again. Because that is the model. And then you can check the port. No, it's fine. And then so the port, which is, so because it's a Mac, anytime you check the port under, it's the USB modem and custom phone number, and in parentheses it'll say that Arduino Nano. If you don't see that, that's an issue, and we need to figure out what is going on.
That'll probably happen at some point today.
It already happened to me. Be very careful with these. I think I broke the first one.
Like change
Oh,
your.
No, not even that. I think it's just I was using it with a breadboard, and I guess maybe one of the fonts like just got stuff. I don't know. But because I plug it in and it never initializes, that port's never detected.
Oh.
Yeah, and so the thing is I tried it. I got the new kit and it worked fine. So initially I thought my computer was like stuck, but I can work with the EEG data, so it can obviously read in information, and the new kit worked. But the old kit didn't work with the new port, so it's not a port issue. So I think I just somehow screwed up that Nano,
Oh.
which great way to start.
Yes.
Yeah, probably won't work. Yeah, I probably won't work. But it's fine. We'll see what happens. Okay, yeah. So link it. Okay, yeah. So we can't do that. Yeah. So we just need to make sure that the board and the port are always at those settings can work. Normally, if your own thing, you want to verify it first. So you just run through it first and make sure there's no errors. So it'll compile. You're going to see a lot of
Yeah.
letters here.
Might be too tiny. Let's see. Survives.
This machine. Takes a while. Honestly, sometimes, yeah. This, or like, if you want to run some bigger, like, machine learning models, particularly. Even if you pre-process everything, it's like, you just have to sit there by your computer for like an hour and just keep making sure it doesn't fall asleep and like stop running everything. So I've had that happen, and it's the worst feeling. Absolute worst feeling.
Well, I have that desktop running. It's not like a machine or anything. It's on my laptop.
Oh,
That's
well, I would have had words. Okay, so that's good news.
okay.
If it just talks about the device on it, use it going,
Yeah.
it's loaded and then it's done as it's loaded. Like it's good. I mean,
Oh, it's working. Wow.
so you
Amazing.
get them on,
Look at that.
Nice. And then you just double click the button on and then you reset everything. Cool. Yeah.
Awesome.
It's simple when you have everything there to run. It's not simple when you don't know what library you need.
Yes. But it's helpful because like I didn't even know that those libraries for tablet for air for use.
Yeah,
So
so
I
I
would
know.
buy those.
Yeah, you can see your connection.
Yeah, I'm not sure, I don't know.
I'll figure it out. Maybe that I won't have a full result today, but that's,
I mean, I don't either.
huh?
I don't either.
Yeah, sure, we won't have it.
That's not bad.
Yeah.
Ugh. Okay, but at least the LED is good strength. So, Jedi. Yeah,
Oh, there you go.
and Snake. It's the wall to.
Yes.
We're going kind of.
Yes.
Okay.
The hard drink.
Bravo.
Yeah.
Especially with the, God, I hate when that happens, especially when it's not like, it's reversed from what.
Okay, but it's all there. Let me get the window cleaner.
I hate it.
Do we even have LEDs for that?
I'm constantly knowing about that. It makes it worse when you look at yourself. It's just like, I can't not like it. I'm just oh my gosh. When Sam gets back here, he's talking about computers because we need to have some. Google it.
That's not bad.
But you know, like a whole alien we can conversation I did with him. Because I have a very weird encounter Tuesday with my friend's coworker. I got stranded at my job before I came back here on Tuesday. It was fine. It turned out fine. Because she was talking to me and my
Quite like me.
husband. She was like, oh, she's talking to you a lot because she sees spirits. And she said that I she said I had good vibes or like good spirits.
All right.
And I was like, I don't know what she's.
It's almost like it matters which direction I'm holding this thing, Stan. Shit.
I mean, it's better than her talking.
Yeah.
I'm just being nice and then her being.
I guess it will be easier if you use RGB on the board, but
Yeah.
you wanted to demonstrate that you can control external devices. Yeah.
Right. Yeah. All right. So.
The set, you know?
Yeah, exactly. It shouldn't. Yeah. That's all right. That's all right. Okay. Okay. So.
So like, it hurts. Not well.
Should I tell you why to it?
Yeah, I think it's a great lie detector if all you do is lie to the machine. Exactly, 100% success rate if you
That sort of cancels out, right? You have to be truthful about.
That's what I'm not hoping right now.
All right. So I am going to check.
I know.
You swear to God,
We'll stay in Michigan.
you just, I don't want you kidding me. So you guys were stressing about the font and the color of.
No, yeah, he had a second copy that was fine, but didn't have to make a new one, we just basically have to square it away first, is what happens. Yeah.
That's
What are
all.
y'all?
Not nothing really, we've been,
Troubleshooting,
in touch with
figuring
some
it out.
machine troubleshooting, learning more about,
And we also aired out.
Oh, okay.
yeah.
Can I?
I'd be sure.
He's not gonna ask for dollar back, we'll get it.
I like to, I mean, it helps us, I won't take that.
Yeah, it's fine. I appreciate it. Hopefully it's $1. It's not that serious.
I mean, you mean something to me, that makes sense.
You know, I feel like we can get this squared away later.
Okay, sure,
Yeah.
sure.
That's more what
I asked them.
I appreciate your focus, but.
The neuro, yeah, this is just a smaller version of these, this is the eye. The neuro, whatever.
Wait, are those even good?
Yeah. They're electrodes that are small that you put here, and these are the smaller suction cup electrodes, yeah. Wait. Yeah, so these are the ones, that are the smaller versions. I know, you take, he said these might be too big. Okay.
How's it going, guys?
Good.
Hey, so I think if you check out the office, I think the lab notebooks will be working. Fingers crossed.
Really? Oh, I love that. The office looks great. It looks, we need to test it out so we'll get it.
I'm gonna go in.
Okay.
Yeah, so it looks like you can do multiple streams, but there's a maximum of 4 per circle. If you walk up to this thing over here, and it should open up our.
Oh my gosh, there it is. I was gonna ask about the.
So that's how we get to the thing.
Okay.
And if you go to your desk, and I just chose your desk at random. Oh, you were setting that up right, so I put you in that one.
Cool.
Since you were fucking using the map correctly, sitting at your desk,
Yeah.
you got top billing.
Thank you, I appreciate that.
So Freddie, I think your desk, so if you walk over these things, I think it's you.
I don't think I have one.
Wait, hold on.
That's
Is it walking by the whiteboard or sitting in the
I don't know
chair?
where I put you.
When I walk by the whiteboard, all the time, the thing came up.
It's the whiteboard.
Oh, okay, cool.
That's yours, okay.
That's cool. It's like they're looking at-
But why is my fish
Is the office now running?
I think so.
That's so cool.
Isn't it cool?
That's awesome.
I think so.
So I
Awesome.
set it up, I started setting it up as anyone in the world can comment, and then I was like,
Oh, there we go.
I made it so that everyone in the world can edit, but then some of them are still a comment, so you guys can fix it yourself.
Wait,
Yeah.
What? Let me check this out.
You gotta see it.
I'll just say
Awesome.
yes.
So then teachers would then be able to fucking edit and comment.
Amazing.
Nice.
Oh, I'm so happy. I love
And then in the TV room, we're gonna set it up so that when they walk in there, it's just gonna have the live stream of the whatever talk is going on. I just gotta figure out from Etienne how the fuck he's doing this shit.
The notebook?
What was that?
Figure out which
Rick?
desk you're, walk by the whiteboard. Maybe you'll sit at the desk.
Yeah, that gets weird.
Whiteboard.
Yeah, that's weird. So, so the goal is that you guys can sit at your fucking desk while you're working at your private. And then, so that way teachers can not fucking bug you, they just wanna see what you're doing. And if you see some stranger looking at your left notebook, you will.
Jason here.
Yeah, may I walk you through it? So it's like, that's a running joke, it's inside,
Ready?
science. Right.
Okay.
Right.
I'll tell them your camera.
They